Good morning, everyone. Let us start with today's session. So, this is lecture number 16 of engineering mechanics. During the last lecture, we were discussing about the equilibrium. What are the conditions of equilibrium and how to apply these conditions to find out the reactions. Okay. So, first we will try to cover the last problem, that is a homework problem. And then I will start with the types of support and the types of loads. So, this was the last problem, that is the homework problem. And in this problem, this sphere or the roller is supported by using this cable. This cable is fixed to the inclined surface. The angle for inclined surface is 45 degree, and angle between this cable and this inclined surface, it is equal to 15 degree. We have to find out the reaction at point C, that is the RC, and the tension in the cable AB. So to find out the tension AB and reaction RC, the first step is we have to draw the free body diagram. So for the free body diagram, isolate this roller from its surrounding and show the different forces acting on that sphere. Okay. So this is the center point of that sphere, that is the point B. The cable AB is connected to this point. So we will represent that cable as a tension AB. So this is the tension vector or the force vector in that cable. Then from point B, the self weight of this sphere, it will act in the downward direction, that is the negative y direction. So this is the weight W, that is equal to 1000 Newton. And there is a reaction at point C. Okay. So this reaction, this is called as a normal reaction. So normal reaction is perpendicular to this inclined surface. So this angle will be 90 degree. Okay. So if I extend this normal reaction, that is the line of action, then it will pass through the center point B. So on this FBD, so this is normal reaction. So this normal reaction is nothing but the reaction at point C. So this is the RC. And this is the line of action. So this line of action of the reaction RC, it will pass through the point B. So in the FBD, there are three forces. One is tension AB. Second is the self weight of the sphere, that is 1000 Newton. And third reaction is reaction RC. So we have to find out the unknown value, that is tension AB, and the reaction RC. So when we solve this problem, we have two equations. One is summation fx0 and second is the summation fy is equal to 0. For such type of problem, so basically this is a concurrent force system. All the forces, they are passing from the same point. Okay. So we will not use summation of moment, it is equal to 0. For such type of problem, we have to only use summation fx0 and summation fy0. So to use summation fx or summation fy, first step is we have to resolve the forces. Okay. That means we have to find out x and y component for the tension AB and reaction RC. So to find out this x and y component, we have to first find out the angle with respect to x-axis. So consider this line as a x-axis and this is the y-axis. Okay. So we have to find out this angle. that is the angle of tension AB with respect to x-axis. So you can observe the given geometry. So in this geometry, this angle is 15 degree for the cable. Okay. Make one construction. Draw one horizontal line which is passing through the point B. So this angle is 45 degree. Therefore, this angle, it will be 45 degree. Okay. We are interested in this angle, that is angle of tension AB with respect to x-axis. So to find out this angle, you can consider this triangle AMB. So this is the triangle AMB. This angle is 45 degree. This angle is 15 degree. So we can find out this angle. So this will be 135 degree. So this is 15 degree. So remaining angle will be, this is 30 degree. Okay. That means angle of tension AB with respect to x-axis, it is equal to 30 degree. Then we have to find out the angle of reaction RC with respect to x-axis or the horizontal. So we can find out this angle. So this is the reaction RC. This is 90 degree. This is 45 degree. So this angle will be 45 degree. Okay. So angle of reaction RC is 45 degree with respect to x-axis. So now you can resolve the forces. So this is the y component. So y component is the opposite component to 30 degree. So this will be tension AB sine 30. And this is the x component, and this is the adjacent component to this angle 30 degree. So this is tension AB cos 30. Similarly, resolve the reaction RC. So this is the adjacent component. So this will be RC cos 45. And this is RC sine 45. Okay. And W, it is acting in the negative y direction. Okay. So there is no need to resolve that W force. Then write down summation Fx and summation Fy. So for summation Fx, tension AB cos 30, this is negative. Then second component in the x direction, this is RC cos 45. So it is plus RC cos 45. It is equal to 0 because we have two conditions. One is summation Fx is equal to 0 if the system is in equilibrium. And second, summation Fy, it is equal to 0. So this will give the first equation. Then write down summation Fy. So for summation Fy, tension AB sine 30, this is positive. Then RC sine 45, again it is positive. And minus this 1000. So rearrange this equation. So shift 1000 on the right side. So we will get the equation as tension AB sine 30 plus reaction RC sine 45. This is equal to 1000. So this is your second equation. So you can solve this equation 1 and equation 2 as a simultaneous equation because we have two unknowns. One is tension AB and second unknown is reaction RC. So the solution of that simultaneous equation will be our answer, tension AB and reaction RC. So I will write this equation in terms of AX plus BY. So first equation is, this is minus cos 30 tension AB plus cos 45 reaction RC. This is equal to 0. Second equation, this is sin 30 tension AB plus sin 45 reaction RC is equal to constant, that is equal to 1000. So this is your equation 1 and this is equation 2. So if you compare this equation with the standard form of the simultaneous equation, then this will be A1x plus A2y and this will be B1x plus B2y. This is equal to 0. Sorry, this is equal to 1000 and this equation is equal to 0. Okay. So you can solve this directly in the calculator. There is a equation mode. So the reaction RC is 896. This is 896.58 Newton and tension AB is 732.05. Okay, so this is your final answer. And the corresponding reactions. So in the types of support, we have 3 types of support. The first one is the hinge support. So hinge support means what? This is the pivot point. And this is the rod. So this rod is connected to this pivot point. So hinge support, it can allow the rotation for the object which is pivoted at this point. Okay. So you can see here in the animation. So about this pivot point, the object, it can perform the free rotation, but we cannot pull the object from that point. That means it will offer the reaction in the horizontal direction and in the vertical direction. So you can see here in the second figure, if you try to pull this object in this direction by applying some pull force, then this support or this pivot point, that is called as a hinge point, it will offer the opposite reaction. So this opposite reaction, it is called as a HA, that is the horizontal reaction. Okay, suppose this point is A, and suppose we try to push this object in the downward direction. Okay, then this support point, it will offer the opposite reaction in the upward direction, that is opposite to the applied force, that is a push force. So this value or reaction, it is called as a VA. So hinge support, it will offer 2 reactions and it will allow the rotation. So these 2 reactions means what? First is the horizontal reaction, that is the HA, and second will be the vertical reaction, VA. Okay. So representation is, if this is the rod, then this is the representation for the hinge support. And when you draw the free body diagram for the hinge support, that means we have to isolate this rod from the surrounding. So this is the free body diagram. At this point, that is the point A, where the hinge joint is connected. This is the vertical reaction VA, and there will be horizontal reaction HA. So this is the free body diagram for the hinge joint. Okay. So important point for the hinge joint is it is having two reactions. One is HA and VA, and second point is it will allow the rotation. Okay. It will not restrict the rotation. So this is the hinge support. Now second support, it is the roller support. So roller support means what? It will offer only one reaction. So this is the reaction RA. It will allow the free motion of that object on the horizontal direction or in the vertical direction. Okay, so you can see here. So roller support, it allows the free movement of the object in the horizontal plane or in the vertical plane. So roller support, it offers one reaction and it allows the free movement of the object in the horizontal direction or in the vertical direction. Okay, so this is called as a roller support. So you can note it down, the types of support and corresponding reactions. And third type of support, this is the fixed support. So for the fixed support, it will offer three reactions. So in the three reactions, the first will be the horizontal reaction, then vertical reaction, and third reaction, it is the moment. Okay, so these are the three reactions offered by the fixed support. Now, how these reactions are offered by the fixed support that you can see here. So this is the rod. It is fixed in the wall. So you can see this is the wall. And if I apply any force at this free end of that rod, then there will not be any motion if this is a fixed support. So this is called as a fixed support. Okay. So what is meaning of there will not be any motion or any movement? So if I apply the force F, then there will be opposite reaction offered by the fixed support. So this is called as a vertical reaction VA. So this is the one reaction out of these three reactions. Then suppose I try to pull this object or the rod by applying some force. Okay. Then this fixed support, it will offer the opposite reaction. So this will be the HA, that is the horizontal reaction. And there will be additional moment reaction. So this moment reaction, it is because of this perpendicular distance. from the fixed support point. Because here load F, that is called as the external load, it is applied at some eccentric distance with respect to the fixed support or the fixed point. Okay. So this eccentric distance D, it will create the moment. That moment value M, it is equal to F into perpendicular distance. Okay. So this moment will try to rotate the complete system or that rod in the clockwise direction. For this example only, because F is acting in the downward direction. So this moment, it will be clockwise about this point. Suppose this point is A. So natural tendency, when we apply this force F, it will be to rotate the system in the clockwise direction. But suppose we want to fix that complete system or the rod, then there has to be opposite moment reaction offered by the fixed support. So this is the reaction, or we can say it is the moment reaction, MA. Okay. And therefore, fixed support, it will have three reactions. One reaction is horizontal reaction, second will be the vertical reaction, and third will be the moment reaction, that is the MA. Okay. So I hope this concept is clear. What is meaning of fixed support and what are the reactions? So HA, if there is any horizontal force, okay, then there will be HA reaction. If there is some vertical force, then there will be vertical reaction VA. And if there is a moment in the system, then there will be counter moment, which is called as a moment reaction. So this is MA. Okay. So these are the three types of supports. The first is the hinge support. So hinge support, it will allow the rotation, but it will not allow the horizontal movement or the vertical movement. So it is having two reactions. One is HA and second is the VA. So you can see here, it will allow the rotation. So hinge support, you can take the example of the door hinges. So for the door, so these are the hinges for the doors. Okay. So because of these hinges, door can rotate about this point. That is the hinge point. Okay. But we cannot pull this door from this point. Therefore, this point, it will offer two reactions. One will be the HA, and vertical reaction. This is the VA. Okay. So this vertical reaction, it is because of this door, it will have some self weight W. So to counter this self weight, there will be opposite force which is offered by the support, which is called as a VA. Okay. Then roller support. So for the roller support, we can take the example. Automobile wheels. So this is called as a roller support. So when you draw the free body diagram for this wheel, then we have to only show a single reaction. Suppose this point is A. So this will be RA and this will be RB. Okay. So roller support, it will offer the movement in the horizontal direction. Okay. And suppose there is one cylinder which is supported against a vertical wall like this, and this cylinder is connected with the help of cable. Then this point, that is a point of contact of that cylinder with the wall, it is treated as a roller support. So it will offer the single reaction. Suppose this point is C, then you can take this value as a RC. Okay. So this is the example for the roller support. So you have to remember, for the roller support there will be only one reaction, and that reaction will be always perpendicular to the surface. Okay. And the third support is the fixed support. So fixed support, it has three reactions. One is HA, second is the VA, and third will be the MA. Okay, so next point is types of loads. So in the types of load, the first load is point load. So point load means what? If the load is concentrated at a single point, then this is treated as a point load. So you can see here example. There are two forces at point A and B. Suppose this force F1, it is equal to 50 Newton, and it is acting at some angle 30° with respect to horizontal. Then this force, it is concentrated only at point A. Okay. The second force F2, suppose it is 20 Newton, and is acting vertically downward along the y-axis. Then F2 force is concentrated at the point B. Okay. So such type of loading, it is called as a point loading. So you can take the example. Suppose we want to pull an object with mass 10 kg, then we can connect a cable at this point. Suppose this point is A. Then the tension in this cable, so this is the tension force. Suppose the cable is AB. Then this tension, it will pass through the point A. So this is called as a point loading. And this is the corresponding motion. Then the second load is uniformly distributed load. So meaning of uniformly distributed load is, if the load is uniformly distributed over the given length or the given span, for the beam or any object, okay, then that loading is called as a UDL, or the uniformly distributed load. So you can see here in the example, so this is the beam AB, and this is the UDL. So UDL, it is represented as a W, and its unit is Newton per meter. So it is similar to the pressure force. So pressure, it has unit Newton per meter square. So we use the pressure when the force is distributed over the area, and if the force is distributed over the length, we use the unit Newton per meter. So this is the load application for the UDL. So you can note down this UDL. So for the UDL, the load intensity, it is represented as W, and unit is Newton per meter. It is also called as a line loading. So for the uniformly varying load, the load is continuously varying along the length of the beam in the linear manner. Okay. So suppose this is the wall, and if the load intensity is continuously varying from this point to the bottom point, okay, and if this load intensity is varying in the linear manner, then that loading is called as a uniformly varying load. So you can see here, this is the load intensity. So at this point, that is the topmost point, the load intensity W, it is taken as a 0, and this load intensity W, it is gradually varying, and it becomes maximum value, that is W Newton per meter. Okay. So such type of load is called as a uniformly varying load. So for the uniformly varying load, we can take the example of the water dam. So in case of water dam, so this is the wall and this is the backwater. Okay, so pressure intensity because of the backwater, pressure at this point, it will be 0. That is the free surface point or the topmost point. Okay, and this pressure, it will gradually change or it will increase and it will become maximum at the bottommost point. So such type of loading, it is treated as a uniformly varying load. So this is the maximum intensity. It is taken as W Newton per meter. Okay, so this is the example for the uniformly varying loading. Now, when we solve these problems for UDL or the UVL, then first step is we have to convert that varying loading or the distributed loading into a single point load. Okay, so we can see how to convert that. So this is the example for the UDL. So this is the uniformly distributed load. So for the UDL, this is the intensity, that is the W, which is equal to 25 Newton per millimeter. Okay, that means for per millimeter, suppose this is the 1 millimeter length. On this 1 millimeter length, force will be 25 Newton. So this is the meaning of 25 Newton per millimeter. Okay. Now consider this total span or total length of this beam. Let us take this as a 5 meter. So this is the point A and this is the B. So beam AB, it is having the length 5 meter. Okay. And the intensity of that UDL, that means uniformly distributed load, it is equal to 25 Newton per millimeter. Okay. Then how to find out the equivalent point load? So for the equivalent point load, so this is the beam AB. We will convert complete this loading into a single load. So this is the F, that is the point load because of the UDL. Its magnitude, it is given as W, that is the intensity of UDL, into the span of the beam, that is W into L. So for this case, W is equal to 25 and length is equal to 5 meter. So this is equal to 125 Newton. Okay. So for time being, consider this is 25 Newton per meter. Okay. So we will get the answer in terms of Newton. So unit for W is Newton per meter. And unit for length, it is equal to meter. So meter and meter, we can cancel out. So remaining value is Newton. That means we get the single force is equal to 125 Newton. And point of application of this point load, it is exactly at the half distance. So this will be at L by 2. And this is the L by 2. So for our example, this is 5 meter. So this will be 2.5 and this is 2.5 meter. Okay. So we have to use this conversion of the uniformly distributed load into a point load when we will draw the free body diagram. Okay. So right now this is a free body diagram for the given beam. So the support reactions, that is the reaction offered by these columns, we can represent as a normal reaction Na, and this will be the second normal reaction Nb. So this is the free body diagram for the UDL. Now, how to convert UVL into a point load? So for the UVL, suppose this is the equivalent point load. This is the W. Okay. So this maximum intensity, it is nothing but the W. This is 0. Okay. Because there is no load at this point. And this span is taken as a L. Then this W, that is a point load, take this value as a F. Okay. We can find out this value by using area of triangle. So this is 1 by 2. Height is W. That is the maximum intensity of the UVL into base, that is nothing but this span. So it is equal to L. So by using this formula, we can find out the equivalent point load because of the UVL, and its unit will be Newton or it is kilonewton. Okay. So for time being, consider so this is the wall AB. Its span is suppose 4 meter. And this is the uniformly varying load acting on that wall. Okay. So maximum intensity, suppose W, it is equal to 10 Newton per meter. And this is the 0. So we can convert this load into a single point load. So this is the point load because of the UVN. So this is F is equal to, use the formula of triangle, 1 by 2, height is 10 into the length of that triangle is 4 meter. So this value, it is equal to 20 Newton. Okay. So this is the conversion of UVL into a point load. Now what is the point of application? So point of application for the UVL, with respect to this 90°, the distance of the point load, it is equal to the L by 3. L means total span or total length. And with respect to zero loading, it is equal to 2L by 3. So total length will be 2L by 3 plus L by 3, it is equal to the L. So for our case, this is 4 meter. So this distance, it is equal to 4 upon 3. Okay. And the remaining distance, this is 2L by 3. So it is 2 into 4 divided by 3. So this is equal to the 8 upon 3. Okay. So this is the location of the point load in case of the UVL. So I hope this conversion is clear to you. How to convert UDL into a point load and how to convert UVL into a point load. So we will use this formula when we will solve the problems on the UDL and the UVL. So if you have any doubt, so with the help of this animation, you can understand how the UVL is acting on any structure. So this is the example of the automatic gate opening mechanism for the water dam. So this is the gate. Then this is the water level, or you can say it is the initial water level. Okay. This is the pivot point. So pivot point means what? This gate, it can rotate about this point. So as this water level is below this hinge point or the pivot point, there will not be any rotation of this gate because the equivalent force because of this water level, it is acting below this pivot point. So it will create the moment in this direction. Okay. So this gate, it will try to rotate in the anti-clockwise direction about the pivot point. But this movement, that is anti-clockwise rotation, it is restricted by this stopper. So this is the stopper. So that gate will not rotate and this water, it cannot flow in the downstream side. Okay. Suppose the water level, that is a backwater level, it starts increasing. Then this UVL, so this is the UVL. So basically this UVL means what? It represents the pressure variation because of the water level on the gate. Okay. So as the water level starts increasing, this UVL will also change. So you can see here. So as the water level is increasing, this F point or the equivalent force point, it is also moving in the upward direction. Okay. So you can see here. So this force point, it is also moving in the upward direction and it is gradually approaching to this pivot point. Once this force, it crosses this pivot point, suppose the force is acting at this point, okay, then it will create the moment in this direction and it will slowly try to rotate this gate. Okay. So gradually it is moving in the upward direction. At this point, this is the eccentric distance, or we can say it is a perpendicular distance with respect to this pivot point, that is a point O. So it will create some force, sorry, moment, which is M is equal to F into perpendicular distance. So this is called as the equivalent force, or we can say it is the point load due to UVL, that is the uniformly varying load. So this is called as uniformly varying load. So this uniformly varying load, it represents the pressure variation from topmost point to the bottommost point. Okay. So at the topmost point, which is in contact with the atmosphere or the free surface, pressure is zero because of the water. Okay. And at the maximum, sorry, bottommost point, pressure is maximum. So generally it is represented as a rho gh. So h means what? It is the depth. So you can see here in the animation. For further increase in the water level, this gate, it will rotate about the hinge point and it will allow the water to flow from upstream side to the downstream side. Okay. So this is the automatic gate opening mechanism for the hydro dam. So I hope this application is clear, how the UVL, that is a uniformly varying load, is created because of the water level. Okay.